Hello and welcome to the topic Matter, Substances, Mixtures, and Compounds. And this lesson is what are the differences in atoms? So when we're studying matter, or the substances, mixtures, compounds, I want you to keep this big idea in mind. And that is, how does the classification of matter depend on the atoms? Now in this lesson specifically, what we're going to learn are where are protons, neutrons, and electrons located within the atom? How is the atomic number related to the number of protons in the atom? And what effect does changing the number of particles in an atom have on the atom's identity? Let's go ahead and begin with some vocabulary. The first word is nucleus. Nucleus is the region in the center of an atom where most of the atom's mass and positive charge is located. You have the proton, which is in that nucleus, and that's the positively charged particle in the nucleus. You also have the neutron. The neutron is the neutral particle within the nucleus. The electron is the negatively charged particle, and that's in the space outside of the nucleus. And that space outside of the nucleus, where the electron is, we call that an electron cloud. The atomic number is the number of protons in the atom of an element. You also have isotopes. Isotopes are atoms of the same element, but they have different number of neutrons. An ion is an atom that is no longer neutral because it has either gained or lost electrons. So let's go ahead and begin your lesson. Atoms are made of several types of little tiny particles, and the number of each of these particles is what makes each atom different from each other. All right, or atoms different from each other. And those three are a nucleus. Inside the nucleus you have neutrons and protons, and then outside the nucleus you have the electrons. Almost all the mass is in this nucleus where you find these protons and neutrons. And again, protons are positive, neutrons are no charge, and electrons are negative charge. An electron's mass is only about 1 in 1,800 of the mass of a proton or neutron. An atom has a center region with all this positive charge, right? Where all these protons are located, and the neutron. And outside of this, you have this electron cloud area, and this is where all the negatively charged electrons are. The nucleus, again, is right in the center, and that has most of the mass. Now, we all know that in that nucleus there are protons and there are neutrons. Protons are positively charged, neutrons are neutral or uncharged. An electron is that negatively charged particle, and it's outside the nucleus. That area where we're going to find the electrons, because remember they don't have specific paths, we just know that this is where they're located. We call that the electron cloud. So it's the area where we are most likely to find the electrons around the nucleus. Now remember that electrons close to the nucleus are strongly attracted to it and have less energy. And the electrons farther from the nucleus are less attracted to it, and they have more energy. So close, less energy. Farther, more energy. And every solid, liquid, and gas is made of millions and millions of atoms. All right? Atoms are really small. So we're made of atoms. Air is made of atoms. Water is made of atoms. If you took the size of an atom and you multiplied that by 100 million, it would still only be the size of an orange you can hold in your hand. The atomic number is the number of protons in the nucleus of an atom. That's how we come up with the atomic number. Every element in the periodic table has a different atomic number. That's how they're divided up. You can identify an element if you know either its atomic number or the number of protons it has. That's how you can find it within the periodic table. Simply know the number of protons or the atomic number. So how is the atomic number related to the number of protons in an atom? The atomic number is the number of protons in the nucleus of an atom. So that's how they're related. The atomic number comes from the number of protons that are within the nucleus. An isotope is one of two or more atoms of an element having the same number of protons, but now the number of neutrons is not the same, because usually you have a balance. And if there's no balance, then it's called an isotope. Now, because electrons are negatively charged, a neutral atom that has lost an electron will all of a sudden become positively charged. So you can see here, it is right here, 2 and 2, all right? If it loses one of its electrons, it becomes positive. If it gains an electron, it becomes negative. So a neutral atom has gained an electron and has a negative charge. So let's look at right here. You have an ion that has a charge because it has gained or lost electrons, right? So here's a neutral atom. You have 4 protons and 4 electrons, right? And it's called beryllium. But then we say, well, look at this positive ion. And what's happened here is now the number of protons are more than the number of electrons. And that's lithium. And that's an example is lithium. An example of a negative ion for nitrogen is because it's gained 3 more electrons than it has protons. Electrons being negative, it has a greater negative charge. This one has a greater positive charge. And this one is balanced. So 4 protons, 4 electrons, balanced. 3 protons, 2 electrons, positive ion. So if the number of protons is greater, it's a positive ion. If the number of electrons is greater, it's a negative ion. Now, when elements combine to form what they call compounds, the number of electrons in the atom can change as they come together. So you can see you have an example here. Here's carbon monoxide, which is a carbon and an oxygen atom. But then carbon dioxide is a carbon atom and 2 oxygen atoms. Same thing for water. Water is H2O. It is 2 hydrogen to an oxygen. But now, if we add 1 more oxygen, it becomes hydrogen peroxide. Completely different. So the ways in which the atom combines can result in many different kinds of matter. There's a huge difference between water and hydrogen peroxide. But the way those atoms combine, because water is H2O and hydrogen peroxide is H2O2, the way they combine can change it completely. So possible changes in the atom. So here we have carbon, 6 protons, 6 neutrons, 6 electrons. So then we add to carbon, add 1 proton. Just add 1 proton to it, and you have a new element of nitrogen. If you add 1 neutron, you have an isotope. If you add 1 electron, you have an ion. So again, carbon, 1 more proton, it's a completely new element because that changes the atomic mass. But a new neutron, it's still carbon, but it's an isotope. Another electron, and it's still carbon, but it's an ion. So what effect does changing the number of particles in the atom have on the atom's identity? Change the number of protons, and the result is a new element. Change number of protons. Change the number of neutrons, and the result is an isotope. Change the number of Sorry, I can't draw that. Change the number of electrons, and the result is an ion. Proton change, new element. Neutron change, isotope. Electron change, ion. So there you go. That's how the identity of an atom will change based on the particles. So in summary, all matter is made of atoms, and atoms are made of protons, electrons, and neutrons. An orange is about 100 million times wider than an atom, and atoms of the same element can have different numbers of neutrons. They cannot have different numbers of protons. Different number of protons is a different element. So, I hope you enjoyed the lesson on what are the differences in atoms, and we will see you in our next lesson.